Hello everyone, my name is Patrick, and I'm here to help you make your first Unity game. Today, we're going to recreate Snake. Recreating classic games is a great way to gain familiarity with Unity, as well as learn some of its basic scripting conventions. Now, by the end of this video, you're going to have a fully working Snake minigame, as well as a basic understanding of the systems we used to make it work. Also, I just want to quickly say thank you to anybody who is watching this video, and I'd like to say keep going, no matter where it is that you are in your game dev journey. Programming, especially for video games, can be really hard to learn and has a lot of difficult and abstract concepts to try to wrap your head around. Don't get discouraged, keep going, and before you know it, it'll click and you'll be able to help out the new programmers around you too. Anyways, let's get to it. Alrighty, so first things first, you're going to want to open up your Unity Hub, create a new project. I'm using Unity 2020.3.8 F1, but any version you use from this one on, the code and everything should work just the same. We're using some pretty basic systems here. So we're just going to go ahead and name this one Snake, and make sure you're on the 2D template, and go ahead and create. Alrighty, now that that's open, the first thing I do when I start a new project in Unity is I usually go up to Window, Package Manager, and then here just make sure it's on End Project from the dropdown. And I just go through and I update any packages that I need that are out of date, as well as remove any packages that I don't need. So in this particular instance, we can see there's a lot that do need updated. So we'll go through and do that real quick. And also, I personally use Visual Studio Community for my code editing and scripting. So I'm going to go ahead and remove this JetBrains writer. And I'm also going to remove this Visual Studio Code. Now, as we can see, there's still 4 things that need an update on my particular version of Unity right now, so I'm going to go ahead and do that, and I will be right back. Alrighty, so we've got all of our current packages updated as they need to be, and we've removed all the ones we're not going to use, so let's go ahead and close out of our package manager. And now we've just got our empty scene. So I'm going to go into this scenes folder down here, and I'm going to highlight the sample scene.unity and press F2 to rename it, and I'm going to rename it to main, since it's going to be our main scene. Unity's asking if you want to reload. Yes, reload. Alrighty, and now that that's done, we can go over to our game window, and as you'll see here, it says free aspect. That means it'll just scale how it pleases. I'm going to set mine to be the resolution of my monitor, which is 1440p, 2560 by 1440. Set yours to whatever your monitor's resolution is, and if you have some obscure monitor that doesn't happen to be on this drop-down list, you can click this plus, and you can put in a custom resolution manually at any time. Alrighty, so now that we've got our game window set to be our monitor's resolution, I'm going to go back to my scene view, and I'm going to click on my camera. And over here on the right hand side, this is called our inspector. This is where you modify properties for the object. So here, if we go down, you can see it has a transform. This transform is its location in the world. So here we can see it's at 0, 0, and then -10 on the Z. So that's in the dead center, but pulled back just a little bit so it can see everything on center fine. Now here under the camera, the property we're looking to change here is the size. Right now it's set to 5. Let's go a bit bigger. Let's go something like 15. And if you go over to your scene view and zoom out, you'll see that that is significantly bigger. Here, let me, so here's 5. And there's 15. So this is just going to allow for us to have a bigger gameplay area without needing any kind of fancy camera controller or anything. So I'm going to go ahead and hit Control S to save. Make sure that it's always second nature to be saving your project after any change, no matter how big or small. Now I am also going to change this background color here, because if we go back over to the game view, you'll see that it's just a blue screen. Now, I have nothing against blue, but I don't personally want my snake to have a blue background. My favorite color is purple, so I'm going to make a dark purple background for mine. You can change yours to whatever you'd like. Click this drop down here, and you can either type in the RGB values, the hex values, or you can just use the color wheel, as I did. Alrighty, so now that we have a camera set up with the background color of our choice, let's go over to the hierarchy over here on the left where all of the scene's objects are contained, and let's right click and go down to 2D object, sprite, and click square. Now immediately it's going to be asking you for a name for this square. Let's go ahead and name it Snakehead, and go over to the inspector, click the 3 little dots by the transform, and click reset. This just puts it back in the dead center of the world at 0, 0, 0. We also are going to want to change the color of this sprite since it is our snake head. I'm going to go with a tealish blue. That nice bright teal blue right there. Alrighty, you can choose whatever color you'd like. Now, also, in order to get this snake to respond to our code and to move around the world, we're going to need to add a couple of components to it. So over here in the inspector, there's this add component option. You click on that, and there's a couple of different ways you can navigate this menu. We could either go down to this physics 2D section and click through until we found what we wanted, or back on the main, we could just type in the component we're looking for. In this instance, I'm looking for Rigidbody2D. Rigid bodies are the system within Unity that allow an object to be placed in the physics system. So as you can see, when we add a rigid body, it gives us a whole bunch of default settings. Like here we can see the body type is dynamic, it has a mass of 1, it has angular drag, and it has gravity. Now because this is 2D, we don't really want any of that. So I'm going to go up to this body type section here and change it from dynamic to kinematic. Now this means any and all physics that are applied to this rigid body have to happen through code. So now that we have a rigid body on here, we're also going to want to add a box collider. Now this BoxCollider2D, we're going to want to make sure it is tagged as a trigger, and this is so that we can trigger various physics interactions throughout our script. You need both the Rigidbody2D and the BoxCollider2D with the trigger ticked in order to get trigger collisions to work. Now the next thing I'm going to do real quick, I am going to change the color of my snakehead briefly. I'm just going to make it dark to show you guys something real quick. You see this green outline around the sprite? That is a BoxCollider2D. Now with its current size, it holds the whole head of the snake, and that's nice, but that's not quite what I want. Essentially, with it like this, there's too much room for error with collisions. So I'm going to drop the size of these down to 0.75. So it has a bit of a border. That way, if the trigger, or if the collision gets triggered, it's certainly hitting, because it's a little bit in there, you know? And now that we've got that set up, I think we're ready to write our first script. So let's navigate back down here in your project tab, click your assets, and now that we're on the main assets screen, I'm going to right click, create folder. I'm going to name this folder scripts. Now for a game this size, it doesn't really matter, but it's good habit to get into to keep everything organized in its own folders, whether it's art, audio, art, whatever it may be. So inside of the scripts folder, I'm going to right click again, I'm going to click create, C# script, and I'm going to name this snake. I'll let that compile for a second. Click on my snake head over here, and I'm going to add component snake. Now that the script is attached, I'm going to Control S, make sure everything's saved up, and double click on my snake script to open it up in Visual Studio. I usually start each new script by deleting these default Unity comments. It's just a preference of mine, you don't have to do that, but if you do want to, you can be anywhere in the line and hold Shift and press delete, and it'll delete the entire line. So I'm just going to clear those two out real quick, and the first thing we're going to need in this script is a variable at the top. We're going to do a variable of vector2 type, and we're going to call this direction. And we are going to go ahead and initialize this variable as vector2.right. This way, the default direction is always right. So that's all we need up here. Oh, I see a typo there, direction. There we go, all fixed up. So Unity by default, just a quick side note, Unity by default recognizes all variables as private unless you specify otherwise. So like in front of this I could put like a public or a protected or virtual. There's a lot of options, but this is a private vector2. I'm just omitting the private keyword for the sake of simplicity. That makes me have to type less. Now let's move down to our update method down here, line 14 for me, void update. And here is where we're going to read input from the keyboard. So Unity's got a couple of built-in ways to go about this, but for the sake of this particular tutorial, we're going to use the older input system, the built-in input system, with some key code calls. To do this, we're going to have to use a couple of if statements and else if statements. Now, if statements are pretty much just what they sound like. If the condition is met, then do the thing. And here, I'll show you what I mean by that. So we can start by saying if, open parentheses. Now we're going to call to that input system I was talking about. So input dot get key down so that we can call the key codes. We're going to do keycode dot w as our first one. Now this here, these two vertical lines, is known as the OR operator. So this will do the command if either condition is met. So in this case, if input.getKeyDown keycode W, or if input.getKeyDown, and we're going to do keycode.up arrow. So if either of those conditions are met, then our direction is now equal to vector2.up. Okay? Else if input.getKeyDown keycode.s will go down this time, or input.getKeyDown keycode.down arrow, then our direction, you guessed it, is going to be vector2.down. Else if input.getKeyDown, we're going to do, let's do left, so keycode A, or input.getKeyDown keycode.left arrow. Then this is going to be direction equals vector2.left. And finally, else if input.getKeyDown keycode.d, or input.getKeyDown keycode.right arrow. Well, then our direction is going to be equal to vector2.right. Alrighty, so that's the end of our update loop. Now we're going to have to move into a different built-in function. So earlier, if you go back to our Unity editor, you'll see that I added this rigid body here. And we mentioned that the rigid body is what allows the object to interact with Unity's physics system. So that's what we're going to do right now. We're going to go ahead and go back to Visual Studio, and we have to implement a different built-in method. So we can do void fixed update, and as you can see, Visual Studio auto completed that for me. I'm going to go ahead and delete that private keyword. And so fixed update is a little bit different than our regular void update. This update up here is called each frame of the game, whereas this fixed update is on a set physics timer that we can change in the editor. So fixed update is going to happen on the same interval constantly. It's like its own little timer, and there's actually a place in the editor where we can go and change how long that timer is, but we'll get to that in a little while. So now we want to set our rigid body's transform position here in this fixed update. So it's actually a lot easier than you think. We just do transform.position since this script is attached to the object, and we're gonna set that to a new vector 3. Now this part's going to look a little weird at first, but I promise I'll explain. We're doing mathf.round, and inside of those parentheses we're going to do transform.position.x, and then outside of the first parenthesis plus our direction.x, and then comma, we need another mathf.round, and in this one it's going to be our transform.position.y, the other part of our vector 2, as well, plus direction.y. And then since it is a vector 3, it needs a z, which is just going to be 0.0f. Boom. Alright, so we did the mathf_round function here to try to simulate grid movement without having to do all the extra work of actually implementing a grid. This is only going to allow whole numbers as the result, as opposed to like some floating decimal points. So the snake's position will move in increments of 1 at a time. So I believe that wraps up our script for now. So let's go ahead and go back over to the editor. Let that compile. Okay. Now I do want to show you guys real quick where that physics timer I was talking about is. So down here in Edit, Project Settings, on the left hand side, if you go down to Time, this fixed time step is what is happening every fixed update. And I'm going to go ahead and double this one. I'm going to set it to 0.04. Let's see what that looks like real quick. Oh, compiler errors, huh? What do we got? Oop, I accidentally put a slash there. Alright, let's go back. Alright, let's try this again. Alright, and there we go. We have a little dot moving around. I did forget to set the snake head color back to that teal. There we go. There we go. Now it stands out nicely. Okay, well, I believe the next logical step would be to make some food. So let's go ahead and right-click in our hierarchy, click 2D Object, go over to Sprites. Yeah, we'll do a square again. Let's name this one Food. Reset it to 0, 0, but then we're going to put the X on -8. So we've got -8, 0, 0 as its transform position. And I'm going to go ahead and change the color of this food to, let's go with bright yellow. Yeah, that looks nice. Okay, so next on our piece of food, let's go ahead and add a BoxCollider2D and set it to trigger as we've done before. And just like we did with the snake's head, I am going to make this box collider a little bit smaller than the actual piece of food is. We're going to go 0.75 and 0.75 again. Just quickly, yeah, that's pretty good. Okay. Alright, and so just double check you've got a BoxCollider2D and it's set to trigger with a size slightly smaller than the sprite itself. Doesn't have to be the exact same numbers I have, those are just the numbers I've tested out and they work for me. So let's go back down into our project down here, click Scripts, let's right click, create a new C# script, and let's call this one Food. And once that compiles, we'll go ahead and add it to our food object. And let's go ahead and open it up. Again, I just prefer to delete these comments. You can keep them if you want. They don't make a difference. They're just comments. Alright, so we don't need any variables just yet, but we are going to go ahead and implement a built-in Unity function down here at the bottom. Function that handles collisions, triggers more specifically. So here, void onTrigger enter. Make sure you're choosing onTrigger enter 2D, as we're working in 2D. And I'm going to change this collision to other, so that is asking, my apologies. So collision is a different call when you're working in 3D. So sometimes leaving that as collision just kind of tangles up my brain. I prefer to switch it over to other, which is the standard convention when you're working with 3D. Like, see, if I do a void onTrigger enter down here, a regular one, see how it makes it collider other? I'm not sure why it doesn't do that for 2D, but I digress. As you probably saw there, I deleted the private keyword. It's no different whether you keep it or not. It's all personal preference. And here in the onTrigger enter, we're going to do another if statement. We're going to do if, and here we're going to call that other from the function itself up here, and we're going to check tag. So if other.tag is equal to player. Now player is a built-in tag to the actual engine itself, and I'll show you how to assign that here in just a second. But what do we want this to do if it's a player hitting it? We want, for now, to destroy the game object, and that should be it for right now, just for testing purposes. We're going to go ahead and flip back over to Unity. Alright, so we need to go to the snakehead object in our hierarchy, and then over here in your inspector, there's a drop down for tag. You see that? Let's go ahead and click that drop down and select player. Also, if you click that drop down again while we're here, go ahead down to the very bottom and click add tag. That'll change your screen to this other screen with a little cog in the corner. It says tags and layers, and tags is already ready for you. It says list is empty, so let's go ahead and press the little plus here. We're also going to need a tag for our food, and later down the line we're going to want a tag for our walls. Alrighty, so now that we're all done with that, it didn't change anything on the snakehead. If you go back to the snakehead, you can see it's still tagged as player. Alright, so now let's give that a try and see what happens. Alrighty, awesome. Okay, so now that the food can recognize a collision from the player, let's have a go at randomizing the food's spawning position. So in order to do this, we are going to need to define a game area. We can do this pretty simply. We can just do it by like adding in, right click in your hierarchy, go to 2D object, sprite, square. We can just name this wall and reset it to 0, 0 for now. And let's zoom out and get an idea where our camera bounds are. And let's go -24 on the X. That looks pretty good. And let's scale it on the Y axis. Let's see, 26, maybe 20, oh, 28. 28 looks pretty good. So we'll do position of -24 on the X and a scale of 28 on the Y, and this will be our left wall. Let's go ahead and you can either right click and duplicate, or with it highlighted, Control D to duplicate, make a second wall, and let's just put that on the opposite. Keep the scale the same, but the position on the X, let's just remove the negative. Alright, let's duplicate it again. Let's put this one back at 1 on the Y, because it's going to be running horizontally, and I want this on 0 for now. Let's see, how far up are we going to want to go? Let's try 12, 14. 14 looks pretty good, and then we should do the scale of X since it's horizontal. I don't think 28, yeah, let's double that. 56, too big. 48, 50. looks like 49 is the magic number this time, so we'll duplicate this, and we just want to invert that Y position again, and there we go. We have a square, well, a rectangle more so, but we have 4 walls. Now that we have those 4 walls laid out, we want to make sure to go through and click on the first wall in your hierarchy, and then shift click on your last wall to highlight all of them, and then go over to add component, and it's still in my search, but just in case it's not in yours, let's go for BoxCollider2D, and make sure it is clicked as a trigger, and we can go ahead and set those that tag right now to walls, since we already made those earlier. Alrighty, so now we're going to want to create an empty game object, and this is going to be our supposed grid. Let's reset it all to 0, and in this we're going to want to add a BoxCollider2D, just like we have to all the other objects, but this one, as you can see, since it's on an empty, where is that? There it is. It's hidden behind our snake head. If we turn the snake head off, you can see that it's literally just an empty object with Box Collider. So we're going to turn the snake head back on. I'm going to go to the grid. Oop. Zoom out. Alright. And from here, we're going to want to go to the BoxCollider2D settings and the size. We're going to want to scale this up pretty big. It's 46 on the X and 22, 24, 26 on the Y. So we don't quite want it overlapping with our walls. We want a little bit of interior just in case, because let's say the food spawns like here. We don't want it to be clipping into the wall, which would just default the player would hit the wall at the same time as the food and lose. So by giving a little bit of a gray area like this, it allows the spawn to be fair. You're going to want to make sure that the box collider on your grid is tagged as a trigger. Okay, and then also I did forget to mention, we're going to want to highlight all of our walls again, and let's see. Oh, actually we're going to have to go through one at a time, it looks like. I don't want the collider to be the whole interior here. I do want there to be a little bit of give, just like there was with the snakehead and with our food and everything else. So if you click this little icon to the right of Edit Collider, you'll see that it brings up these little handles. I'm going to grab that handle that is dead center here, and I'm just going to pull it in a little bit. And I know it's a little hard to see against white, but if you zoom in, you can see it a bit better. And you can really see it over here in the settings. It's changing the offset as well as the size and the x-axis. So I'm just going to go through one at a time and do that to all of these again. Let's see, wall 1 was the right one. They're not going to be identical since I'm not duplicating that first one and I'm doing them all by hand. That's okay. They don't have to be. Alright. So now that those are there, and they're all tagged with walls, make sure you're saving. Now we are going to go ahead and go back to our food script. So, okay. So up at the top, we're going to want to add a new variable. This one, we want it to be able to be changed in the inspector. So normally, in this instance, I'll see a lot of people just say to use a public variable, but for the sake of teaching, I am going to use a serialized field. That way the variable remains private, but it's still accessible in the inspector. And while I'm here, I do want to mention the designations at the beginning, like that public, private, serialized field, those declare the access level to the variable. So if it's private, it can only be accessed within the script that it is contained in. If it's public, other scripts can call it, And serialized field acts the same as private. It's just in the inspector, in the Unity inspector, you can actually assign an object to that, as you will see here. So we're going to do a serialized field of BoxCollider2D, and we're going to call this the grid. And let's see, we don't need our update for this script, so we can go ahead and delete that. And in its place, let's create our own function. We're going to say void randomize position, open and close parentheses, and open and close curly brackets. So the BoxCollider2D contains within it what are called bounds, which gives us the exact size of the box collider. So what we're going to do here, the very first thing, is declare a new variable of type bounds, and we'll just call it bounds, and that's going to be equal to the grid that we assign in the inspector, dot bounds. Simple as that. And then now we're going to create two new floats to represent our vector 2 real quick. So float x is going to be equal to random.range, and the range that we're going to be randomizing between are our bounds min x, so the minimum x of our bounds, and bounds max x. Now we're also going to create a float y, and it's going to be much the same. However, it's going to be the minimum and maximum bounds of our y. Simple as that. So now, at the bottom of this function here, we're going to say transform dot position. So the object that this script is attached to, that transform, and that's going to be equal to a new vector 3. And again, we're going to use mathf round to get a nice whole number so that it acts like a grid. Mathf.round, and we're going to be rounding our x variable, and then also mathf.round for our y variable. And then since it is a vector 3, we do have to tell it what z is, which is just 0.0f. And now that we have this new function, this randomized position function, let's go ahead and call it in start, which, if you didn't read the comments or you don't know, start is called at the very beginning when the game is first run. So in this case, right when we first load, we're going to run this function, randomized position, which is going to check the bounds of the grid that we assigned in the inspector and determine a random spawn point based off of the minimum and maximum x and y positions. And it's going to set the position of the object this script is on, so the food, to whatever the product of these two random generations are. And since it's assigned in start, we're also going to assign it here. Instead of just destroying the game object, let's go ahead and call randomized position so that we get more of that classic snake feel. And once you get that, we can go ahead and save that off and head back over to the editor. Alrighty, so back over here in the editor, you want to make sure that on your food object, you drag the grid into the grid over here in the inspector. If for whatever reason you can't drag and drop it, you can click this little target to the right. Okay, let me show you. So right now we're back to none, no box collider. If you click this little circle over here, it'll give you an option of every object of that type that's available in the scene. So here in parentheses you see it's BoxCollider2D, because back in the script we declared that it had to be a BoxCollider2D. So this is looking for any BoxCollider2Ds that are available in the scene, and you can just select grid from here. Okay, so I think, let's see, player, trigger, kinematic. I think we are ready for another test run. Let's see. Nice. Nice. All right. So this is working as we expected. However, doesn't feel much like Snake. Yes, the food is spawning in random places, but you don't die when you hit the wall, and you don't grow. And most of the fun of Snake is growing, in my opinion. I like seeing how long I can get without hitting myself. So let's make that happen. So what we're going to want to do, the best way to go about this is going to be to duplicate our snakehead object. We can just, in the hierarchy, we can right click and either duplicate or highlight and Shift D, or Control D, my apologies. I'm going to rename this to snake body, and I'm also going to remove the Rigidbody2D. We don't need to control any of the physics on this piece. And I'm going to remove the snake script so that we don't have any issues with multiple instances of a script later. Alright, so if you look here, I'm going to disable the snake head so that we can see just the body. And since they're both on 0, 0, they're stacked and you can't really see. So here on the snake body, I'm going to change the color just a little bit so it's more obvious what's the body and what's the head. So our body is that nice teal, or our head's that teal. Let's make our body like that. That looks pretty cool. Okay, so then we'll turn our snake head back on, and now we're going to make a prefab out of that snake body object. So if we go to our project and our main assets folder, we'll right click, create a new folder, call this prefabs. Again, you don't need to do this for this particular game, it's just a good habit to get into. So here in the prefabs folder, I'm just going to drag this snake body object into the prefabs. And you see over in the hierarchy how it turns blue? That means Unity has created a prefab of it, and I can now delete it from the scene, and it exists within the data for the game. So now we can use our script to call this object, since the data is already contained within the game, and spawn it at the back of our snake. So let's go ahead and do that. Let's go back to our snake script, which is on our snake head. And we're going to need a few new variables up at the top here. So right under the direction, actually we'll go above it, right above direction. We'll start at the very top here. Our first thing we're going to want is that prefab, so we're going to do a serialized field again, which again is a private variable, so it's only accessible by this script as far as calling it. However, we can change the game object itself in the inspector and any various values if we were to do a float. But for this instance, we're doing a transform, and let's call this our segment prefab. And this will represent our segment of snake. Next, we're going to need a list of transforms that we will call segments. And we want to initialize that as a new list of transforms right away. So this list is going to contain all of the body parts that we add on as we get more food. And we're gonna want to create a new method down here at the bottom of the script to take advantage of those variables. For the sake of simplicity, let's call it boy grow. And let's see. What we're gonna want to do inside of this is we're gonna want to get a new transform that we'll call segment again. And this is going to be equal to instantiate segment prefab. Okay, so what this essentially means is anytime we call this variable segment, it's going to instantiate whatever prefab we have assigned in the variable, or have assigned in the inspector. Now we want to set the position of that segment. So segment dot position equal to our segments list. Anytime you are referencing into a list, you need to use square brackets. So we're going to do segments dot count minus 1. And I see over here that auto-corrected. This should be segments count minus 1 dot position. So what count minus 1 is the current list length. So the current amount of segments that we have minus 1. So the last one. So this is going to set our new segments position at the end of our list. Okay. And then finally, we want to do a segments.add call, and we want to add in this new segment. And just like over in our food script, we're going to want to add onTriggerEnter2D here. So we're going to do a void onTriggerEnter enter2D, and we'll do Collider2D, and we're going to call it other again. Alright, now for this one, we're going to say if the other object we are colliding with is tagged as food, then we're going to grow. Alrighty, so now each time that our snake, the object that this script is attached to, collides with any other object that's tagged as food, it's going to grow, which again creates a new segment piece from our prefab and sets its position at the end of the current segments list. Alrighty, let's head on back over to the inspector and take a look at what we've got so far. So our food, we need to make sure we change that tag to food. And also just make sure everything else is in order. So our snakehead is tagged as player. It needs the segment prefab assigned over here in the inspector. So click on your snakehead, go back to your project. So in this instance, as soon as I click the prefabs folder, my inspector is going to disappear. See how it's gone now? And now I can't drag this snake body in there anymore. So, I mean, I could obviously just click on or open up the folder and then go up to snakehead and drag it in that way. Or I can click snakehead and click this little padlock on the top right of the inspector to lock the inspector. Now, no matter what I click on, it could be grid, it could be wall, it could be scenes, doesn't matter, the inspector is going to be locked to the snakehead object. So now with the inspector locked, I'm going to go ahead and drag my snake body prefab into the slot on the snake script and unlock my inspector. And let's give this a try. So that's doing something weird. Why is it doing that? So, okay, so we actually need to go through and move each piece of the already existing snake in reverse order so that we can spawn a new piece in the back. So yeah, let's go back into our snake script, and at the top of our fixed update, we're gonna write a for loop. So instead of a normal for loop, which if you type for and then hit tab, it'll automatically fill one in for you. As you can see here, this for loop is ascending. We're gonna wanna go backwards. We're gonna wanna descend. So our for loop is going to look a little bit different. In fact, I'm just going to go ahead and delete all of that, go back to just the keyword for. I'm going to type it in myself. We're going to do for int of I, which is segments, dot count minus 1, so that it's the last object in the list, I greater than 0, I minus minus. Alrighty. Segments I position is going to be equal to our segments I minus 1. Oop. I minus I minus 1 dot position. Why is that being like that? Oh, that's because I added a semicolon there. Simple syntax error. Okay. And out of concern that I didn't quite explain it correctly while I was fumbling around with it there, this for loop here is just starting at the end of our list and going backwards until it reaches 0. We're also going to want to add another tag down in our onTriggerEnter2D section. If you remember earlier, we created the tag for the walls and assigned it to them. So right underneath our if statement, we're going to do an else if other.tag equals wall. Then we're going to want to reset the game. Now, we don't have a reset game function yet, so let's go ahead and create that down at the bottom. Void reset game, open and close parentheses, open and close curly brackets. Alrighty, let's have a think here. What do we want to do when the game resets? Well, I know we're going to need to clear out our segments, so the best way to go about that is with a for loop. So we're going to do for int of I equals 1, I less than segments dot count and I plus plus, and we are going to destroy segments at position I dot game object. So what's this doing? This is going through our entire snake, skipping the head. So if you notice, it's not starting at 0, it's starting at 1. So every object after the head, and it's destroying them upon game reset. So next thing we're going to want to do is we're going to want to clear out the list. So segments.clear. And then even though we didn't destroy the head, we did clear the list. So we want to do segments.add, and we're adding this, so transform, since it is a list of transforms. And let's see, I do believe we're also going to want to reset our or assign our transform. So we'll do transform dot position. We'll set that equal to vector3.0 so that we're in the dead center of the screen. And let's call reset game as soon as the game launches, because now once the game launches, we will start as just a head, courtesy of our for loop, with a new list assigned. The head will be the beginning of the new list, and we'll be starting in the center of the screen. Okay. I think that might be it for our snake script. Let's go ahead and save it off, hop back over into our editor. Alrighty, let's press play and give this a try. Real quick, I do just want to double check. Okay, so we've got the walls all tagged as walls. Ooh, I'm seeing something here. So my tag is walls. In the script, I put wall. So I am going to go back. I could just add an S. Yeah, I'm just going to add an S in the script, actually. Walls. See, that's the issue I have with string references, is that it's got to be exact, and that's just a little tedious. Sometimes you can get errors for things that were an oversight. Alright, so it looks like those are all tagged food is tagged and it's a trigger. Our grid is assigned. Snake has the body assigned. It's tagged as the player. Oh yes, really quick, we're gonna wanna make sure that our snake body prefab is tagged with the same tag as the walls, because as I mentioned at the beginning, we want our snake to be able to bump into itself and die. So since our functionality to reset the game is hooked to that walls tag, our snake body will also go on the walls. Alright, let's save it off and let's see what we've got. Oh, I hit the wall and reset. There we go. As you see, we get a piece of food, adds on to the back of our snake. Hit the wall and it resets us back to nothing. Alrighty guys. Well, there we have it. A very, very basic version of Snake. Real quick, before I end this video off, I do want to show you that speed is only adjustable. The way we've made these scripts, the speed of the snake's only adjustable right now through the project settings under the time and the fixed time step. So for instance, right now we're at 0.04. If you remember, the original default setting was 0.02. So if I do that, I'm just going to dock my settings over here real quick. If I change that to 0.02 and I click play, look at how fast the snake moves now. It is significantly faster and it'd be a lot harder for people to play it. Now on the flip side of that coin, if we look, let's double our original, so 0.08. Now the snake's just crawling along. It looks like we've got a very low FPS and that we're lagging, but in reality it's just moving once every 0.08 of a second. Alright, so I'm going to reset mine back to 0.04, and I think we're going to end this one off here, guys. Thank you so much for watching. The full project will be available on GitHub. I'll put a link in the description. I appreciate all of you. Yeah, have a good one. See you all soon.